All right, so in today's lesson, we're going to be looking at two-way tables. All right, and you see an example of a two-way table right here. So let's first of all describe what this is. Okay, this table here shows the results of a survey that we did with 200 people, and they were asked their age and also whether they are for or against building a new park downtown. So this kind of a survey can be run, and we've basically broken it up. So we have two different questions that we were asking them, and those questions had categorical answers. Now the age initially would be a number, but we could group them into these age ranges. Okay, so what is a two-way table? It's a table that compares different variables, in this case, age and their stance on whether or not to build a park downtown. And those are variables that are divided into categories. And also, we include totals for each row. So notice here, this row all adds up to 50. This row here adds up to 75. This row adds up to 75. And total for the columns. Okay, so this column adds up to 105. This column adds up to 170 or 70. This column here adds up to 25. And actually, if you look at the total column, it adds up to the 200 people we surveyed, but also this total row adds up to 200. So it's a great way to like check when you're building these to make sure that you got everything right. You don't just take it for granted, but make sure these both add up to the same amount. Okay? The grand total here is that 200, and that was the 200 people that we surveyed right there. Okay, so let's just real quickly make sure we understand what this table is telling us. First of all, let's figure out some of the values in here. How many people are ages 41 to 60? So here we don't care about their opinion, all we care about is their age. So we look at this row, and over here there are 75 total people ages 41 to 60. All right, so that's 75. Um, how many people are for building the park? So here we don't care what age they are, we just care about how many are for it. So we see here 105 people are for building the park downtown. Okay, so now those are some pretty basic ones, but now we look at some of these combinations. Here we have or. How many people are ages 21 to 40 or over 60? So we look at the total for ages 21 to 40, that's 50 people, and or over 60. So there's 75 people over 60. So we're actually going to add these two values, 50 plus 75, and we get 125 people. Okay? So if it's an or like that, you need to add up both categories that it's asking you about. Okay. Now this one over here, how many people are ages 21 to 40 and against the park? When we see this word and, we need to think it's got to fit into both categories. So ages 21 to 40, that's this row right here. Okay, and against the park, that's this column right here. Okay, so the people who are ages 21 to 40 and against the park are just this group of 20 people right there. Okay, so there are 20 people who are ages 21 to 40 and against the park. All right, so now we have some other combinations here. Over 60 and have no opinion. So here are all the people over 60. Here are all the people who have no opinion. So that is, there are 5 people who are over 60 and have no opinion on this park. Okay. And then we have another one that's written a little bit differently. At least 41. Well, at least 41 means that they could be 41 to 60 or over 60. And all right, so that includes this right here. That's everybody over 41 and for the park. So that would be this right here. Okay. So it includes this group of 30 and this group of 50. So that 30 plus 50 gives us 80 people who are at least 41 years old and for having the park built. Okay, so that one was a little bit different. You got to think about these, but if you look at your table and even use a pencil and do this so you can erase, or use technology so you can erase even easier like that, and actually draw what you're looking for. Okay. Now there's a couple of other questions here. As we look at this, which age group was the smallest? So age group, we're looking at the totals. So I look at these totals for the age groups, and the age group that was the smallest was this 50. That's the ages 21 to 40. Okay, and that might be important if we're doing a survey to recognize, hey, there might be a group of people that are underrepresented in this. Maybe to make it fair and get a good cross of all three age groups, we might want to go out and find 25 more people to survey who are in this age bracket. Okay, or we might not. We may be satisfied with these results and just leave it at that. Okay, now. If these 200 people were to vote, would most people vote for the park? Well, most means more than half of 200. Okay, more than half of 200. So if I'm looking at this column right here, the ones who vote for it, I should say this row, are 105. So yes, most would, because 105 people are for the park. Okay. So that's what a two-way table is. That's a basic way of how you can use it to identify things. I want to take a quick moment here to actually construct one. We looked at the totals and whatnot, but sometimes this can be a little bit tricky. So I want to look at a different scenario and construct one real quickly. So let's suppose we ask 50 Sweetwater students whether they like chocolate ice cream. Okay, whether they like chocolate ice cream. But you have a little trouble collecting all your data. We lost some things. So here's what we do know. All right, there were 10 sixth graders and 25 eighth graders surveyed. Okay, 7 of the sixth graders said they like chocolate ice cream. 10 seventh graders said they did not like it, and a total of 30 students said they liked it. Okay, so let's start filling in what we know. First of all, we had 50 total students. Now that's our grand total. That's going to go down here in this corner right there. Okay, so there's our 50 students total. All right, so how do we set up our columns and our rows? So we got to think about the two things that we would have to ask them. And you might say, well, we only asked them one thing. Do they like chocolate ice cream? All right, well, what's the alternative? They like it or they don't like it. All right, they don't like it. All right, well, what was the other thing we asked? Well, in order to know, we know they're all Sweetwater students, but we were keeping track of which grade these kids were in. So we're going to separate this into sixth graders, seventh graders, and eighth graders. Okay, so now we can start filling in some of the gaps of what we were told. There were a total of 10 sixth graders. So that means the total of this column is going to be 10, and 25 eighth graders. So the total of this column is going to be 25. All right. Now, another thing we're told is we were told that 7 of the 6th graders said they like chocolate ice cream. So here's a 6th grade column, like chocolate ice cream. So that's these guys right here. So there's going to be 7 of them there. All right. 10 of the 7th graders said they did not like chocolate ice cream. So here's our 7th grade column. Here's don't like. So that's 10 of those. And then we said a total of 30 students said that they like chocolate ice cream. Okay. So 30, this like row has to add up to 30. Okay. And believe it or not, this is enough information to figure out everything else. Those of you like puzzles, if you've ever done a Sudoku, it's kind of like that, except we're adding things up instead of um, getting numbers 1 to 9. All right. So let's figure out a few things that we can pretty easily. All right. So here, if we look at this total column, we see 30 plus something has to add up to 50. So if 30 students liked it and there were 50 students total, that means there had to have been 20 students who do not like chocolate ice cream. Okay. Also on this total row, we have 2 of the 3 values. So 10 plus whatever this is plus 25 has to add up to 50. Okay, so 25 plus 10 is 35. And if I subtract that 35 from 50, that means I must have 15 7th graders. Okay, so already we can use the totals. Remember, every column has to add up to the total at the bottom. Every row has to add up to the total on the right. Okay, so we actually can very easily get these two boxes. Since there were 10 sixth graders and 7 of them like chocolate ice cream, that means 3 of them did not. And since there are 15 seventh graders and 10 do not like chocolate ice cream, that means 5 don't. Okay, again, we have to make these add up to 15. So 5 plus 10 is 15, 7 plus 3 is 10. Okay, now we can work our way across. We can't just do the same thing here because we don't know either of these. But if we look at along the row, we knew that 30 students liked the chocolate ice cream. So 7 plus 5 plus whatever this is has to add up to 30. Okay, well 7 and 5 is 12. If I subtract that from 30, that means there are 18 students who are 8th graders who like chocolate ice cream. I could do the same thing along this row here. 3 plus 10 is 13. 13, I'd have to add 7 more to get 20. Okay, so 3 plus 10 plus 7 equals 20. Now I can double check my answer by adding these two together. 18 plus 7 equals 25. Okay, so when you're done with these, always check every column. 7 and 3 equals 10, 5 plus 10 equals 15, 18 plus 7 equals 25, 30 plus 20 equals 50. And then check all your rows. 7 plus 5 plus 18 equals 30, 3 plus 10 plus 7 equals 20, and 10 plus 15 plus 25 equals 50. When you get all those to be right, then you've got your two-way table set up correctly. Okay, so that is the initial idea of how we would set up a two-way table, and that's what the different values mean. In our next video, we're going to look at how to actually use these.